Hi guys, it's Mrs. Middleton. Okay, we're going to learn about the law of sines today. All right, the law of sines simply says that in every single triangle, the ratio of a side to the sine of its opposite angle is consistent throughout a triangle. Okay, so we do our ratio of the side over the sine of the opposite angle. You can also flip these. You can put sine of A over little a. I just tend to favor that. But this is nice. It's consistent throughout every single triangle. So as long as you have one of these pairs, you can use the law of sines. Okay? All right, so let's look at our different scenarios. The first one is angle, side, angle. So I've got an angle, a side, and an angle. Okay? So if I think about this, I've got to find that third angle, which is pretty straightforward because I know all three angles have to equal 180. But I got to find those other two sides. Now, if we look at this just conceptually, there's no other option here, okay? So that side can't change. These two angles that can't change. So this has to be the only triangle because I can't pivot this angle, like I can't make this angle bigger or smaller because then that would change these other angles, okay? So when we have angle, side, angle, this is it. There is only one triangle, okay? So let's go ahead and I'm going to label my A, B's, and C's, and of course it doesn't matter, just be consistent. So angle A, I've got side A opposite, angle B, and side C I actually have. So here's actually the ratio that I have because I know angle C is 180 minus 46 minus 72 degrees. So I know that is 62 degrees. Okay, so that's the ratio I have. I have C over sine of C, so I'm going to do that one first. So I have 6 centimeters over the sine of 62 degrees. Now I don't know little a, but I do have its angle. And I don't know little side B, but I do have the angle opposite it. So here's my full ratio. So I'm just going to do a little bit of cross multiplying with these two to find A, and a little cross multiplying with these two to find B. So if I cross multiply to find A, I'll do A sine 62 equals 6 sine 46. And then to isolate A, I'll just divide by sine of 62. Put that in the calculator. You can put it in the calculator too. So I get A equals 4.9 centimeters. Okay? So this is 4.9 centimeters. We'll put our angle in there for C as well. Okay, so now I have A. The only thing I left to find is B. So again, I'll do some cross multiplying of these two proportions. So B times the sine of 62 equals 6 times the sine of 72. And of course, to solve for B, I'm going to divide both sides by sine of 62. So I get B equals 6.5 centimeters. Okay, and again, just kind of glancing, I always just kind of double check. There's my smallest angle, that's my smallest side. There's my largest angle, that's my largest side. Okay, and let me just show you on this one example how these ratios do hold true. Okay, I won't do it on all of them. So if we do A, so A is 4.9 over the sine of 46, I get approximately 6.8 something. Okay, now remember, I rounded that, so my numbers aren't going to be exact, but they're going to be very close. And then we've got B, which is 6.5 over the sine of 72, and I get about 6.8 something. And then C is 6 over the sine of 62, and I get about 6.8, okay? So the ratio of a side over the sine of its opposite angle, or I could have done the sine of 62 over 6, sine of 72 over 6.5, and so forth. The ratios are consistent in every single triangle. So it's kind of nice. Law of sines is very nice. Okay, so there's our first type of triangle, angle, side, angle. Second one is going to be angle, angle, side. Okay, so I have an angle, angle, and a side. Now let's look at this to see why this only has one triangle. So that side's not going to change, these angles aren't going to change, but these two sides might be able to change. But again, if I try to, you know, make this side longer by lifting this side up, I've lost my 83-degree angle, okay? I can't bring this one down or bring him in because I've lost my 75-degree angle. So again, angle, angle, side is only going to be one triangle, okay? I'll do this in green. So let's put our labels here and we will see what ratio I have. So I have the B ratio. So I'm going to start with the B ratio. So I'm going to put 8 over the sine of 83. Let's see, A I don't have, but I do have its angle. C, side I don't have, but I do have the C angle. Because if I have 2 angles of a triangle, I have all 3 angles. I just have to do a quick little calculation here. What is that, 22 degrees? So side C over the sine of 22, okay? So now I'm good to go. I'm going to do a little cross multiplying with these 2 ratios to solve for A and cross multiply with these 2 ratios to solve for C. Okay, so we'll cross multiply. Let's do this side first. A times the sine of 83 equals 8 times the sine of 75. Then, of course, to solve for A, we're going to divide by the sine of 83. Stick that in the calculator, and A is 7.8 centimeters. Okay? All right, let's use these 2 ratios to solve for C. So C sine 83 equals 8 sine 22. And again, to solve for C, we will divide by sine of 83. And then I get C equals 3.0 centimeters. Okay, I'm going to label up here. I always like to see my triangle. And again, I always just double check. Smallest angle, opposite smallest side, largest angle, opposite largest side. Okay, and again, if you want to take the time and put 7.8 divided by the sine of 75, 8 divided by the sine of 83, and 3.0 divided by the sine of 22, your ratios will be consistent. Okay, and of course we are rounding, so all the decimals won't be exactly the same, but they'll be very, very close. Okay, so that's my second scenario, angle, angle, side. Okay, now the third case is side, side, angle, but we call this the ambiguous case because there's actually 3 different options. Okay, there's actually 3 different options. For a side, side angle, there can be the option of no triangle, which we're going to look at in detail. There can be the option of 2 triangles, or there could possibly be just one triangle. Okay, so let's look at these individually. Okay, let's look at the no triangle. So I have a side, and an angle. Okay, and if I think about it, I do have a ratio here. I have a side, opposite, and angle. Okay, so I do have a ratio for my law of sines. I can't find the other angles right away because I only have one angle. So I have this side, so I should be able to find this angle. But you'll notice I drew this to scale. This actually can never be a triangle. Okay, so these 2 side lengths aren't going to change, and that angle's not going to change. I'll put my spaghetti noodles here. So I can pivot this side because this angle can change, right? I don't know the angle yet. I don't have to keep it still. But no matter how I pivot this 3 centimeters, it will never hit that side, okay? Because this angle won't change. So my 8 centimeters, it can't pivot. So I don't have a triangle, okay? Now you're not going to draw stuff to scale, okay? You're just going to probably jot down, if you're told side, side angle, you're probably just going to jot down something like this, you know, just to roughly draw. So you can draw it and it looks like a triangle, but when it's to scale, it actually is not a triangle. So how do we know it's not a triangle? all right? Well, we're going to find out when we do the calculations. I'll do this color. Okay, so we'll do A, B, and this angle down here would be C, okay, if it actually created a triangle. So we're going to do our ratio that we have. Oh, let me do my A, B, and little c. So I actually have 3 over the sine of 37, and I'm going to do 8 over the sine of c, okay? So here I'm going to cross multiply to solve for c. So I'm going to do 3 sine c equals 8 sine 37, and then to solve for the sine of c, I'm going to divide by 3. So I have sine c equals 8 sine 37 over 3. Okay, now how do I put that in the calculator? To solve for an angle, you have to hit second. So second sine, and I'm going to put that ratio in. 8 sine 37 over 3. And I get an error. Okay, so the fact that I got an error, C doesn't exist. Okay, well, why did I get an error? I'm going to come up here and grab that and just get rid of the sign. Because that ratio is greater than 1. Okay, and we know the sine of an angle cannot exceed 1. Okay, so the sine of any angle, the sine cannot be greater than 1. Okay, so the fact that I set this up, because again, I'll probably just sketch it like this. I set up my law of sines ratio and I tried to solve for the second angle, but I got an error. So that means there is no triangle, okay? Because again, you're not going to draw things to scale. I never draw things to scale. I just did it for this example, okay? So that's how we determine in side-side angle that there's no triangle, okay? Let the calculator give you an error. Okay, all right, let's look at the second option for side-side angle. Sorry, I'm getting all my papers organized. Okay, so let's look at this a little closely here. Get my spaghetti noodles. Okay, so again, I've got side-side angle. This angle can't change, so these two are not going to pivot, but this angle can be whatever. Okay, so my 5 centimeter side here can pivot. Now, if it pivots up, forget it. It's not, the 5 centimeters isn't going to meet, so that's not going to create a triangle. But it can definitely hit and create one triangle there. But if I pivot the other way, look at that. I actually have 2 triangles. That's what this triangle is. Okay, so this 5 centimeters can either create this obtuse angle, a triangle with an obtuse angle, or a triangle with an acute angle. Okay, so in this case, so again, here's the exact same triangle, but I took my 5 centimeters that was over here, and I pivoted it this way. So this scenario of 5 centimeters, 10 centimeters, and 26 degrees can actually be 2 triangles. Okay, and again, I'm not going to draw things to scale. How can I figure that out when I'm calculating? All right, so let's do a little bit of calculation here to figure out how we're going to see these 2 triangles. All right, let me label. I'm going to call this A, B, and C, and I'm going to call this A because he's not changing. I'm going to call this B1 and C1 because they're actually a little different. Okay, so let's see. This is A, this is C, and this is B. So this is A, this is C, and this is going to be B1, okay, because this will be different than that, all right? So again, what ratio do I have? I have this side and this angle, so that's the ratio I'm going to write up, 5 over the sine, the sine of 26. So of course, that's the only other side I have, so I'm going to do 10 over the sine of C, okay? And again, I would do that over here as well. I don't have to do it twice. So let's do a little cross multiplying. So 5 times the sine of C equals 10 sine of 26. And of course I will divide by 5. So sine C equals 10 sine of 26 over 5. Let's put that in the calculator. Second sine, 10 sine of 26 over 5. And I actually get an angle, okay? I didn't get an error, So C in this case is, what was it, 61.3 degrees? So this is 61.3 degrees, okay? Now, that's not what this is, but there is a relationship between these two angles, okay? If you think about this, where's my spaghetti noodle? Trying to find my 5 centimeter spaghetti noodle. When I pivoted this, okay, this little chunk I took out of here was actually an isosceles triangle, okay? So this is the 5 centimeters on this side, okay, with my 61.3 degrees now. And then when I pivot it, this is the triangle I'm pulling out. This is 5 centimeters on that side. Well, we know in isosceles triangles, opposites, sides opposite congruent angles, or angles opposite congruent sides are also congruent. So this is also 61.3 degrees. So if I take this triangle and think about it sitting right here, if this is 61.3 degrees, what's its supplement? Okay, so I just have to take 180 minus 61 degrees. What is that? 118.7. So I know once I find this angle, I know C1 over here is simply 180 minus 61.3 degrees. Okay, so that's 118.7 degrees. So I'm going to label that. And it makes sense. It's an obtuse angle. Okay, so now I've got the other sides. Now, now I've got two angles. Finding B and B1 will be a piece of cake, right? So angle B is simply going to be, in this first triangle, 180 minus 26 minus 61.3. So angle B is 92.7 degrees. And angle B1 in this triangle is 180 minus 26 minus 118.7. So that is 35.3 degrees. Okay, so now I've got all my angles of my two triangles. Okay, the only thing left to find is side B for this triangle and side B1 for this triangle. So again, I've got my original ratio, so I'm just going to set it up again. So I'm going to do my 5 over the sine of 26 equals B over the sine of 92.7 for this triangle. So let's see, B times the sine of 26 equals 5 sine 92.7. Divide both sides by sine of 26. Stick that in the calculator, and I get 11.4 centimeters. Okay, now over here I got to do a whole nother calculation. I'm going to do my first ratio, 5 over the sine of 26 equals B1 over the sine of 35.3 degrees. So B1 sine of 26 equals 5 sine of 35.3 with my cross multiply. Divide by sine of 26 on both sides. And B1 equals 6.6 centimeters. Okay, so that's how I know I have two triangles, okay? Because once I find one angle, that second angle, I find its complement, okay? And then if I have a third angle, I'm good to go, okay? Make sure you can see everything. All right, and again, you won't have drawn these things to scale to be able to pivot one of the sides. So you've got to rely on the algebra to tell you whether you have two triangles or not. Now, what happens, how do I know if I don't have a second triangle? Let's look at the third scenario. My third scenario is side-side angle, but only one triangle. So I have my side-side angle. So if I think about this, I think that's my 7 centimeter spaghetti noodle. If I think about the other two, it's definitely one triangle because when I pivot it down, it can hit the other side. If I pivot it up, that's not going to work. So I got to bring it down. So that'll be one triangle. But if I try to pivot it the other way, just like I did before for the two triangles, oops, trying to do this without shade. All right, when I come over here, it's not building another triangle, okay? It would have to have stopped somewhere along the way, and the 7 centimeters is just way too long. So this cannot pivot and create two triangles, okay? It's gonna fall outside the triangle if I try to follow the line, and then I've lost my 45 degrees. So it's no longer the option of two triangles. So this one is one triangle. All right, so how do I tell algebraically? Because again, you're not gonna draw things to scale. Let me get a different color. So if we do A, B, and C again, let's see what we have. This is little a, this is little b, and this is little c. Okay, again, got a full ratio. So 7 over the sine of 45. And this is the one I'm missing, or the one I can find first. I have 4 centimeters over the sine of c. So I'll do my cross multiply. Divide by 7. So sine c equals 4 sine 45 over 7. Put that in the calculator. Second sine, my 4 sine 45 over 7. And I get what, 20, where am I, 23.8. Okay, so this is 23.8 degrees. Now, I don't know that I only have one triangle. I definitely have one triangle. So it isn't this case. I didn't get an error. So no triangles out of the options. So I definitely have at least one triangle. But how do I know if I have two triangles? Okay, so if there's at least one, you got to check to see if there's two. So I'm just going to kind of do my angle check first. So, ooh, sorry guys, just hit my tripod. So if there was a second triangle, okay, I would have a second option for angle C. So I would say C1 is 180 minus 23.8, okay? And that's 156.2, which makes sense because I knew it would be an obtuse, okay? Well, if I have an A and C, I can quickly find B. So I'm going to come over here. B is 180 in this triangle minus 45 minus 23.8. So B equals 111.2 degrees, which makes sense, okay? But if I come over here, my second B should be 180 minus 45 minus 156.2. So that's my whole triangle minus my A minus my C. Well, if I stick that in the calculator, I get negative 21.2 degrees. Well, I can't have a negative angle, okay? So this second triangle does not exist because of that negative third angle, okay? Another way you can do it, if these two, if this angle, if the second angle you found and the first angle are greater than 180, you know you don't have a second triangle. But I do have at least one triangle, okay? So I can finish finding side B for this second triangle. So again, if you guys don't mind, I'm just going to put my ratio up here. So I'm going to put B over the sine of 111.2. Do a little cross multiplying here between these two. So B sine, sine of 45 equals 7 sine of 111.2. Divide by the sine of 45. Stick that in the calculator, and you get 9.2 centimeters. Okay, and I always like to double check. Smallest angle, smallest side, largest angle, largest side. Okay? Okay, so that is the law of sines. Okay, so let's recap real quick. Let me get all my papers here. Law of sines is that the ratio of a side over the sine of its angle, and again, you can switch these. You can do the sine of an angle over its side, is consistent throughout a triangle. Okay, so when we have angle, angle, side, okay, we have a pair, so we can start our ratio and we can solve for the other sides. Third angle is a piece of cake. When you have two angles, third angle is a piece of cake. When we have angle, side, angle, It doesn't look like we have a pair, but if we have two angles, we basically have all three angles. So we have our original pair for our ratio, and we can solve for our other two sides, and we're good to go. But the ambiguousness comes with side-side angle. So we will either have no triangle with that, where that one side is just not long enough to complete the triangle, and when we do the algebra behind it, we get an error and we're trying to find that angle because it doesn't exist, okay? The second option for side-side angle is perhaps two triangles. And this is where that second side can pivot. So it can be an acute triangle, but then it can pivot to be an obtuse triangle. So that pivot creates that inner isosceles triangle that helps you find the two values of these supplemental angles, okay? And then we can finish finding the rest of the sides and angles. So when we're doing our ratios, 5 over the sine of 26, we do have a full ratio, okay? And we use the other side, and we look for that second angle, and we have the complement of the second angle, and then we can go from there to finish the triangle, okay? And then the last one is side-side angle, where there's only one triangle. And again, you're not going to draw things to scale. When you set up your side-side angle, we know visually this is only one triangle because that can't pivot and create an acute triangle. But when we do our calculations and we do our ratios and we find that that second angle, we can find its supplement. You know, you can always subtract it from 180. But when we go to find the third angle, okay, if it's negative in the second triangle, then there is no second triangle, okay? So for side-side angle, if you have one triangle, you always have to check for that second triangle, okay? Don't ever assume it's just one triangle unless you have discounted or disqualified the fact that there is no, or you've disqualified a second triangle. Because over here, it worked out. We actually had a second triangle. Okay, well, I hope this was helpful and helped you visualize side-side angle in all the different scenarios. And I'll end it with that, and I'll see you next time.